So in a lot of ways, this wrapping up is sort of a repeat of the discussion that we had, because I think that a lot of us got talking about what was the takeaway from this, and a lot of those thoughts ended up in the wrap-up slides, and then of course a lot of those thoughts came out during the question and answer. So I don't want to just say the same thing at you, although I probably will. If there is feedback during it, some of the discussion topics, let's just go ahead and we can kind of do it as an open discussion too. So there's kind of a meta message here, which is all of us on this side who are standing up here and talking to you, as Barry said, there shouldn't be this big divide between us and you. We're all here because we kind of believe in this paradigm that there is a community, there's an HPC community. We all have somewhat different roles in it. But when you engage in it, it's sort of a matter of what you put in, you get out. And so that's kind of the meta message here. There are a lot of different points I would make, but they'll probably come out. So this was a picture that Lois showed this morning. And you can think about this, the bigger sort of scientific enterprise. Anybody who can code well can go find a job in Silicon Valley. They are hiring, I know, because they're taking my postdocs. So yes, they're hiring. So in some sense, the reason that we're all here is because maybe, well, okay, some of you are probably destined for that, which is fine. But a lot of us actually do care about the science at the end of the day. And so we want that scientific outcome. And I know that we've talked a lot about software, and you might think that that's all we think about. But I mean, in the end of the day, I do this because there is a scientific outcome. I don't want to do this for Google. I don't want to do this for Facebook. But science is a big enterprise. And so, like I said, I really do believe in the concept of team science and that there are a lot of contributors. This is a nice graphic. And when I look at that, my reaction is, God, it makes me tired, because how are you going to do all of that? You know, we already say that, okay, well, there's the people who do the experiments and the people who do the computing, and then there's all kinds of other people. But if you look at this, even if you're the HPC person, the modeler, there's all these pieces. And none of us actually does all of this. And maybe the professor at your university says they do it all, but really they've got a horde of 10 graduate students. So the thing that I always come back to is, in this big picture of doing science via computation or via computation plus experiment, where do you want to spend your time? That's really what it comes down to. The other thing I ask people a lot is, what do you like to think about? You know, when you go home and you're taking work with you, what is the part that you hate to think about? I personally hate to think about compiler versions. I want it all to just work. I don't care why GCC 4 point whatever didn't work with this. I don't want to think about that. I love thinking about algorithms. That's where I want to spend my time. I like to think about discretizations, how spatial and temporal discretizations work. And sometimes it's fun to think about how to make it go fast. But the point is, there are things I like to think about and things I don't like to think about. And I think if we're honest with ourselves, that's probably true for all of us. And Mark was saying that one of the things he loves about his job is he kind of gets to choose to work on the things that he likes to think about. And I happen to know from many email exchanges with Mark that he thinks about a lot of different things a lot of the time. But we do it because there is some fun in it, right? I mean, we're doing this for a reason. So that's the question I would say to ask yourself is, where do you want to spend your time? And you may not have the luxury of actually spending all your time there now. I don't think any of us actually does. But it's a good guidepost. It's a good way to think about your direction. I'm sorry, it's the end of the day. It's long. OK. So coming back to, this is actually all about science. OK, so what do you have to do science? Well, you have to have, again, if we're in some physical world, you have to have some physical model. So the expertise there can be very domain specific. I'm sure you guys have all heard about we talk about the language barrier. You know, a biologist talking to a computational person, we just don't mean the same things even when we say the same words. There are conversation after conversation. I have conversations with a computer scientist where the first time we have the conversation, I understand the top 10%, maybe 5%. The second time, I get the next 10%. We're supposed to be in the same field, but it takes that iteration. So in the physical space, and then, the computer science space is down here, the mathematical space, there are people who know techniques that I don't know, and I should take advantage of that. Discretization and algorithm development. Like I said, that's where I like to spend my time. But I also like to talk to all these other people, and then parallel implementation. if you can run it faster, if you can run a bigger problem, you can do better science. So that's a win. But the point is, that's a lot of expertise. And I would argue that none of us in this room has all of that expertise. We are not the best at all of those things. So how do we optimize our impact? I mean, I think, at some level, we all like to make a difference. We all like to feel like what we did, what we spent our days doing, mattered in some form. Having impact, having a result in some form, makes us feel good about our jobs. So you've heard me say this too many times. In an ideal world, you get a bunch of people together. Everybody's doing what they're best at and what they love, and they're contributing, and they're talking, and they're talking just the right amount and not too much that you can't get any work done. And you have all that expertise in one team. And the problem, of course, is that most of us don't live in that work world, right? We don't have all the expertise there. The computer scientists, the biologists, whatever, we're not all on the same team. One of the things that a lot of us at the labs talk about is the way the funding works now. We are pulled in so many different directions that we just crave getting to work on one thing. We're probably on 10 different teams. We're not able to focus on that. But the point is, that's a great scenario. I really like that scenario. But one of the things that, if we can't have that, shared software is one of the ways to encapsulate the expertise. And I think that that's important because it may not seem when you download a package and it doesn't work that there's a lot of expertise behind it. But so you don't realize that those of us who are suppliers are also users. So if I try to link with sundials and it doesn't work, and expletive deleted sundials people, why don't they build good software that just works? So the point is, there's a lot of expertise out there, and Dan and I don't work side by side. I can't go and knock on his door and say, oh, come on, Dan, make it work. So good quality software is a way that we share that. So you've got expertise, obviously, in discretizations and algorithm, hardware, software, parallel programming models. When this works, it's a really good thing for all of us. Okay, so you remember Mark's very, very first example, which seems like a really long time ago and wasn't 1D time independent. Wonderful. If that's your assignment for the day, for God's sake, don't spend your day on Google trying to download a software package to do it. Right? Mark had wrote that program in about 10 minutes, or probably by the 50th time you've written it was pretty quick. So there's no point in going and learning a software package. So we all agree with that. The other thing, and I don't want to discount this, is that simple is often a great place to start, right? So I will admit that when I read resumes for people who are applying for HPC jobs, if their programming expertise stops at MATLAB, I stop reading, okay? True confession, if you're going to do HPC, put something beyond that on your resume. That said, MATLAB can be a great place to prototype. So when you're designing an algorithm, and you don't want to write 1,000 lines of code before you know whether this idea has any legs at all, prototype it. So, write it in MATLAB. Run it in Serial. Don't worry about parallel issues. Demonstrate that proof of concept. This is a very, very legitimate thing to do. You do not need an external software package for that. So new algorithms, this is often where they come from. They're designed and they're validated in this mode. And then the other thing we talked about is sometimes it's a good learning exercise. If you write a multigrid, I actually just walked a student through writing a multigrid solver recently. It's a good way. You've seen it in the book, but you weren't quite sure that restriction versus prolongation, exactly what do you do, and are you coarsening the correction or the residual, and which one do you interpolate? And there's nothing like learning by doing. So that has a value, but you've got to balance that with wanting to get something done at the end of the day. So again, we've talked about writing your own. We all like to think we write perfect code. I know from first-hand experience I don't. So I'd rather blame Dan for the bugs than have to find my own. And then this reinventing the wheel. There's a trade-off. Okay, so first of all, so Mark and I, we were talking about wrap-up slides one weekend. Said, Mark's going to be the end of the day. We really don't want a lot of equations. Let's put some pictures. And I think Mark was a little punchier than I was. So all the cool pictures are credit to Mark. He had a little too much fun. This is the serious one here. So we've said this already, right? We're people too. We're doing the best we can. We have funding constraints. We have time constraints. We have kids we have to pick up from school too. And maybe you were going to run that one more unit test before you did the push. And okay, things happen. But that's a good thing. Okay, so I guess the point of this is that, yes, people who write software and have the guts to release it and say, go for it, use it, we think it's right. We know a lot, but we don't know everything. And the other thing to realize is that we can't anticipate every way in which you might want to use it. And maybe this is more AMRX specific, because one of the coolest things for me is we put in some functionality, and somebody says, well, I want to do this thing that's kind of like what you support, but not really the same. Can I do that in AMRX? And we say, not today, but tomorrow you can. Because we didn't think of it. We didn't know that somebody might want to do that. But they did, and for us, it's an obvious extension. That's great, because I'm happy because somebody's using it, and by using it, they're also testing it. But they're doing something. They're getting science done. And for them, instead of them having to say, oh my God, I've got to go into the guts of AMRX, and I've got to learn all this stuff to make this one-line change. So that kind of relationship is a good thing. So let's call it communication and collaboration. You heard Barry talk about how a lot of Petsy developers started as Petsy users. Obviously, there are funding issues. Not everyone, therefore, gets a job at Argonne National Lab. But, well, Barry, you did say you're hiring, right? Or, Barry, you just want them to free pull requests?
I want them to work for me for free.
Oh, OK, there you go. So, Petsys, there you go. But this really can be a win-win. I'll fit the gender stereotype and talk about relationships. So there are real people who read, if you do a pull, everyone know what a pull request is? Sort of, yes, OK. So there are people reading your pull requests. Tone matters. I'll tell you the one that never gets a good response is, it doesn't work, can you fix it? Take it to the bank, we have all gotten that one. Would you care to specify it? But there's a tone, there's a level of professionalism and courtesy that if it goes one way, it will come back. You can develop that working relationship. You can find out which codes will, or which development teams will respond to your GitHub issues, your emails, whatever their mechanism is. I will tell you right up front, there's a list of codes, and those people won't answer your questions. I'm not going to tell them to you, but there are, and you'll find out. Try email, and you'll find out that there's some that do. Okay, that matters. And we know that matters. Yes. Okay, so here we are. We're giving you this hard sell. One of the frustrations on the supply side is, my God, we're making this great product. We want people to use it. We're telling them about, why don't they? And so what we kind of came up with is there are two main reasons. One is, yeah, I know there are all these tools out there. This is a courtesy of Mark picture. There are all these tools out there, but what are the chances that one of them actually really does what I want? I will tell a hyper story from back in the day where we wanted to have an external multigrid solver. We said, we're so tired of writing multigrid. And what we had is we had a 5-point stencil, but in certain places we wanted to extend it by 1. So we needed the flexibility to go out from not just to I+1, but to I+2. So we downloaded it. We started working on the interface and looking at the documentation. Couldn't find anything about how to do that. How do I specify that? Finally, I email or call somebody I know on the hyper team. I said, OK, I give up. How do I do that? And they said, oh, well, that doesn't support that. You can't do that in hyper. So how much time have I just wasted to find out that it doesn't do what I want it to do? And so, quote, we know this, right? We get this. There's a trade-off in documentation. Do I tell you every single thing I know about AMRX in the documentation? No, because you'll never get past page 1. So there's this balance in we want to give you enough to get started. We want to be there to answer questions. But we also understand that it's not super clear. There isn't a checklist that you put in what you want and it pops out with this is the code you want. If it does exist, if I tell you, oh yes, there is such a thing, well, where is it? How do you use it? And again, will it work with your other tools? Maybe you're already using one package and you want to be able to call both of them. Can you even build them together? And that's one of the things that XSDK is trying to address is, yes, you can build with both of them. They've promised you that that will be possible. OK, and the other reason I think we don't talk enough about this is frustration. It's the same thing we're talking about. OK, I downloaded this. I'm trying to get it to work. It's not working. And at least if I wrote it all myself, I know it's my problem. But if I downloaded it, I don't actually know, maybe maybe the tool wasn't really designed for that. Maybe it actually doesn't work in that case. Maybe I'm just calling it wrong. And if I contact the developer, they're just going to tell me it's my fault. So one of the reasons, so the facilities were recently talking to various software people. And anybody know what CI is, continuous integration? OK, so CI and regression testing means, yes, you can test your code on their machine in this case. And CI is sort of a more regular testing, regression testing, maybe nightly. One of the great, there are a lot of great reasons to do this. And we're talking about you want to test it on a lot of different machines. But one of the reasons is, let's say, I'll take NERSC because that's the one closest to us. Let's say they run a code suite every night of 20 different codes. If one of the codes breaks, you can probably say, OK, the bug is with that code team. You probably don't know how many times we've done battle with the facilities where we say, something changed in your system. It's the operating system, you change compiler. They say, no, your code's broken. We say, no, we didn't change anything. It's your problem. Back and forth, back and forth. So one of the great things, if they test 20 codes every night, and if one morning 20 codes didn't run, then I don't have to do battle with them. It's their fault. It's their problem. They will fix it. So anyway, how do you know if it's you? How do you know if it's them? Again, some great graphics. The wrong tool, using the wrong tool, using the tool wrong. So how do you find it? How do you use it? We get this. We actually spend a lot of time trying to think about how do we write the documentation? Which tutorials should we have? Does anybody ever actually look at them? And the answer is yes. It's a moving target. And I guess the message is we're all in this together. OK, so this is where the software community is going, right? The idea is we don't want to have one over here and one over there. And that screwdriver isn't compatible with this hammer. Well, that analogy doesn't work. But the idea is, yeah, you kind of want to have a toolbox. And it might be a very big toolbox. And you should not actually have to download the entire toolbox because it might overflow your disk. But you should have some way of saying, I want to use this. I want to use this. They will play nicely together. That is the ideal scenario. That is, the software developers know this. They are working towards it. But it takes time. It takes resources. And it takes things like continuous integration at the facility. So when I say the facilities, I typically mean what they call the leadership class facilities. There's one at Oak Ridge, one at Argonne, and then NERSC at Berkeley. We're all working towards this, but there's a lot of interrelationships, and nobody can do it without the other ones sort of marching along with them. So users, you're part of this. So we kind of all want to move forward together, advance the state of the art, without any one party having to absorb all the frustration. OK, this is just the trade-offs that we've talked about. And I guess part of the message to you guys is, yes, the frustration is real. We get that. It frustrates us that you get frustrated because we all want to go and do our science and design our algorithms and all of that. Challenges. Yeah, you got to learn something new. The hard to predict showstoppers, that's the one I really hate because if I just spent a week on it only to find out, oh, no, it doesn't do that. It's really frustrating. Not always plug and play. Sometimes what should work, oh, you made an assumption that I was going to give you a vector that was 16 long, and I gave you a vector that was 32 long. I mean, there are things like that who would have thought? There's some more subtle ones. Do you trust this package? Do you know those people? Do they do good work? Trust. Collaborating takes time. It takes conversations. It takes repeated emails and repeated interactions. I would argue that there's a payoff. But in that moment, when you need a result by Friday, you maybe don't have the time. I can't remember where we were going with funding priorities. It's always a question. It's always an issue. Where were we going with that? Do you remember?
Well, just that it affects which features ultimately
right.
are
yes. OK.
top of the priority list.
Yes.
Getting it happening.
Right. So I want a multigrid solver that will take an extra, I plus 2, comma j. The people writing the multigrid solver say, I'm sorry, we've got a list of to-do things, and these are the ones we're funded for. Sorry. I think you kind of know the advantages. We've talked about that. One of the things that it's something that I've harped on at other times. People sometimes get into a mode where they say, OK, this is what I have, and so I'm going to make sure I write an algorithm that works with what I have. And I've seen this where you ask somebody, why are you doing an explicit method? And if people were listening to Dan, they know the difference between explicit and implicit. An implicit method requires some sort of solver. And I've had people who said point blank say, well, I didn't want to write a multigrid solver, so therefore I'm doing an explicit method. That's the wrong reason. So the science should drive the algorithm. You should do the right algorithm scientifically, mathematically, algorithmically. You should not choose that algorithm because that was the only software you knew about. Okay, that's kind of a pet peeve. Again, the idea is you spend less time writing debugging, more time doing the fun stuff, which is the science or whatever it is, and the community. I mean, that's one of the things we're really trying to give you as a takeaway is we want all of you to join this community. Okay, tipping the balance, this is just a repeat of what we said. So something new to learn, we are trying to ameliorate that. Examples, tutorials, documentation, work in progress. I love Barry's idea of if you want to test the waters and see how a team responds to you, offer them a paragraph saying, you know, the documentation was here, would this help? Because a lot of times we don't know how users see it. So we don't know at what level to write it. So I thought that was a great idea for how to start engaging with the team. You can see how they respond. Do they ignore you? In which case, okay, you haven't invested very much. Are they appreciative and incorporate it? In which case, it's kind of cool. You can show it to your mom, right? Hey, I wrote that. See, it's in print on that website. You gotta take your credit where you can. Okay, the showstoppers, again, I should have made that phone call to the hyper team way earlier, before I got frustrated. Hey, does this do that? Yes, no. Plug and play, again, issues, and then XSDK is trying to address this. Trusting others is testing. Relationships matter. You'll be a lot happier in your career if you have the right ones. Funding priorities, again, the developers they don't always have the time to do it. If you know how to do it, and we actually have a collaborator right now, he said, I really want a multi-component solver. We said, we don't really have a driver for that right now. He said, well, would you mind if I wrote it and contributed it? All good, all good. In fact, I just tested it out today. So we make our software open source because we want people to use it. It's not behind the fence, it's out there. It's out there for everybody to see every single mistake. It's in GitHub, you can see every commit I did that I had to revert. You get used to that. We want you to succeed, right? That's why we're here. And if something's missing, we've said ask. Okay, so this is just Barry's point again. Many contributors started as user. So if you like to code and you don't have a big software project of your own and you want to contribute, go for it, right? I mean, this is again, it's a win-win. So think about, participating in this. And that does it. Thank you. Questions before dinner? Yeah.
I just have a quick question.
Yeah.
So for some of these repositories that are hosted by national labs,
Yes.
How much can we assume that like asking somebody on your team for help is built into their funding? Where I don't feel like I'm taking on their personal time by asking them to.
So I'll tell you point blank, it doesn't matter. Okay? Try. Because you'll find out real soon.
So we expect you'll set your own boundaries for what you are not able to do.
So okay, for all of you who are graduate students, I've heard so many graduate students worry about hurting their advisors' feelings. Don't worry about hurting. No, the way you're going to hurt my feelings is by being really rude to me, in which case I'm not going to respond to you. So people have, I'm here today. I'm not answering emails about stuff. People have different lives and levels of busyness, but try. So it's not the national labs are funding people to do this. A lot of it comes down to the individual team members. Some questions are super quick. Some questions, if you say, hey, can you implement this for me and it's your thesis work, we're going to say no. But basically, we want you to try. And I said, you'll find out soon enough who responds and who doesn't. There's kind of a reality out there.
So these will be good dinner time conversations to have informally. Thank you so much, Anne. So we'll have dinner and then we'll resume back here at 6:30. For those of you who indicated interest in meeting with subject matter experts, us here, we're working on a schedule for that and we'll communicate with you about that during the evening session. So we're able to accommodate everyone. You'll be meeting in groups of 1, 2, or sometimes 3, just depending upon how the schedule worked out. Thank you.